Alright, so we're going to talk about adding and subtracting fractions. Now, before we get to fractions, I want to talk about 4 problems, and they're kind of basically the same, but I want to get across a certain point. What is $7 minus $3? Well, of course, it's $4. 7 apples minus 3 apples is 4 apples. 7 miles minus 3 miles is 4 miles. 7 whatevers minus 3 whatevers is, of course, 4 whatevers. Doesn't matter what is there, what kind of the unit is. So if it doesn't matter what the unit is, what is 7 tenths minus 3 tenths? And remember, a tenth, we know what a tenth is. A tenth is something where if you have 10 of them, you put them together and you have one whole. So 7 tenths minus 3 tenths is, of course, 4 tenths. And, well, we can just write this in fraction notation. 7 tenths minus 3 tenths is 4 tenths. So remember, this is just telling you the object, the size of the object, the denomination. So if we have 7 of these tenths minus 3 of these tenths, well, of course, we have 4 tenths. And again, there's nothing special about subtraction. All of this stuff works with addition as well. So something like, I don't know, 2/5 plus 1/5 is, of course, 3/5. So in essence, there's not too much more to say about addition and subtraction of fractions if you're happy with that idea. I mean, what about if you have unlike denominators? So something like, I don't know, let's say 4/7 minus 1/2. Well, now, it doesn't kind of make sense to just subtract the numerators or subtract the denominators or anything like that. Remember, these denominators here, that just tells you the size of the object. So 4/7 is we have 4 of these sevenths. And a seventh is an object where if you have 7 of them together, you get one whole. So we don't know, in some sense, how to subtract these fractions, but remember, we can always find equivalent fractions. So we can multiply top and bottom by 2 here, top and bottom by 7 here, and then we get 8/14 minus 7/14. And now we know how to subtract those. That's really easy because we have the same denominator. And that is 1/14. So basically, the rule, if you will, is you can only add and subtract fractions with a common denominator. And I think we all know that, but I just wanted to stress the point that really it's just the same thing, 7 whatevers minus 3 whatevers. And those whatevers, as long as they're the same things, you just subtract them, how many you have. And the whatevers in this case are pieces of a whole. Alright, so I do want to make one note here. When you are finding common denominators to add or subtract fractions, in fact, let's make this a -31. These could be integers, so we might as well have an integer in there. Okay. But when you are finding common denominators, so you can add or subtract rational numbers, you should try and use the least common multiple of your denominators rather than just blindly multiplying by the opposite denominator. Like, that would work, don't get me wrong, but it would be a lot more labor to get the correct answer. Let me show you what I mean. So let's pretend we don't see that 16 times 4 is 64, and therefore our least common multiple of 16 and 64 is 64. So that would be our best common denominator, but let's say we didn't see that, and we're like, okay, I guess I'm going to just multiply by the other denominator. So we'll multiply top and bottom of this fraction by 64, and top and bottom of this fraction by 16. Okay. So our common denominator, 16 times 64, is 1024. Now 7 times 64, I don't know what that is. Let's check. So 28, carry your 2, 56, or sorry, 7 6s are 42, plus 2 is 44. So 7 times 64 is 448. And 31 times 16, I don't know what that is. So this is going to be 6, 18, and 31. We add 496. Okay. All right. Now we have to add these integers, 448 plus negative 496. So we subtract them. We keep the sign of the larger magnitude. So it's going to be 496 minus 448. 16 minus 8 is 8. 8 minus 4 is 4. So we get 48 over 1024. But we should reduce this fraction to lowest terms if we can. So let's cancel out some common factors. I see a factor of, let's say, 8 here. 6 8s are 48. And I know that 1024 is 2 to the power of 10. It's just a bunch of 2's multiplied together. Here are 4 2's. Here are 6 2's multiplied together. So I'm going to divide top and bottom by 8. But if you didn't know that, you could find the GCD of these guys and just divide top and bottom by that. 48 divided by 8 is 6. 1024 divided by 8 is 128. But hey, look, there is another factor of 2, so I'll factor that out. And finally, I guess, 3 over 64. And that was a lot of work just to get the answer 3 over 64. If I did it, what was it, over 16 plus negative 31 over 64. If I did this, oh, before that, I did make a small mistake here. This should be negative 48. Because I forgot that 448 plus negative 496, I'm going to keep the sign of the larger in magnitude numbers, 496. So this is negative 48, negative 6, therefore negative 3. So my mistake. But we just fixed that. Okay, so back to this problem. If I find the least common multiple, in this case it's quite easy, it's just 64. And you can check that if you want. Find the prime factorization of both of these guys, and you should be able to find the least common multiple from the stuff we've done in a previous video. So now we get, well, 7 times 4 is 28 over 64, plus a negative 31 over 64. So this is going to be 28 plus negative 31 over 64, which is, of course, negative 3 over 64. So you can see how much work you save by using smaller denominators. The lowest common multiple being your common denominator is a very, very important thing. All right, so I just want to quickly talk about mixed numbers. So if you remember, mixed numbers have a whole part and a fraction part. They're not used as often in non-American places as they are in the States, but it's still good to know how these are used. So let's say we have something along the lines of, I don't know, let's do 3 1/3 minus 4 2/5. No, let's do, sorry, I'm going to change that, 4 5/6. That's better. Okay. So, now there are ways, of course, to deal with the whole parts and the fraction parts separately. In fact, you can kind of borrow from the whole parts to get an extra, in this case, 6/6 or 3/3. But that just kind of gets confusing. I find the easiest way to do it is just convert to improper fractions. So, let's go ahead. So, 3 1/3 is the same as, well, this is the same as 3 wholes, so that's 9/3. So we have 9/3 plus 1/3. We can look at it like this. So, well, let's do it like this. So 3 times 3, so that's saying how many thirds we have from our 3 wholes. We have 9/3, and then plus the extra 1/3. So that's how many thirds we have. And then we're going to subtract. Well, we're going to have 6 times, or maybe already does 4 times 6 actually. 4 times 6 plus 5, that's how many sixths we have. This 4 wholes is the same as 24 sixths. So 24 sixths plus the extra 5/6 here. So this is the same as, oh, that's not what I want. This is what I want. 3 times 3 is 9 plus 1 is 10/3. 4 times 6 is 24 plus 5 is 29 sixths. Okay? And now, well, we should get a common denominator. And again, the easiest thing is to realize that the least common multiple of 3 and 6 is 6. So 6 times 1 is 6, 3 times 2 is 6. So I'm going to multiply top and bottom of my second fraction, of my first fraction to get a denominator of 6. So this is 20 sixths minus 29 sixths, which is, of course, negative 9 sixths. And then we ask, is there any common factors? I see a common factor of 3. So I'm going to divide top and bottom by 3. That's the greatest common divisor of 9 and 6. So this becomes negative 3 halves. And then finally, well, we were given our numbers in mixed number form, so our answer should be in mixed number form. So how many wholes can I make out of 3 halves? Well, I can make 1 whole with 1 half left over. Remember, to convert from an improper fraction to a mixed number, you just divide. So this is your quotient, and that is your remainder. And of course, our answer is negative, so we'll put a negative in front.